write logarithms, this particular first rule is called the product rule. So the product rule is when you have a logarithm with a base, and then the argument is actually two expressions multiplied together. So we have two variables here, m and n, or two expressions, m and n. So what we're going to do in order to rewrite this as a sum and difference of logarithms is to write two logs with the same base as the original. We'll write the first expression first behind that first logarithm, and the second behind the second logarithm. And if these two things are multiplied together, when we separate it into two logarithms, we're going to add. So let's do that right here. We have two expressions, s and t. They are being multiplied. So if we have two expressions and we want to write this as a sum and difference of logarithms, we're going to write two logarithms with the same base as the original. So log base 3, log base 3, log base 3. The first expression, s, is going to go first, and the second goes second. And the key here is if they are being multiplied here, we're going to add these two logarithms in our answer. Okay, in a similar way, we can use the quotient rule. So instead of multiplying, we're dividing. The same thing applies. Log base a is written twice. The numerator is written behind the first logarithm. The denominator is written behind the second logarithm. And if we're going to divide, we change that division to subtraction when we write 2. Okay, so let's do the same thing here. We have two expressions, 3 and x. We're going to write two logarithms with the same base as the original problem. The numerator goes behind the first one. The denominator goes behind the second one. And if we're dividing, we subtract in our answer. The next part is called the power rule. So if we have some expression that has a power to it, notice that I'm not multiplying any two expressions together. I'm just taking one expression and raising it to an exponent. Notice also that my answer still just has one logarithm based on that one expression. The only difference is that this exponent, instead of being an exponent now, it went to the front. So that p goes to the front of that logarithm, and this becomes p times log base a of m. Let's see how that works down here. So notice that I still just have one expression. I have q raised to the 7th power. So I'm just going to write one logarithm with the same base as the original problem. The variable part here, the base of this exponential, is going to go in the back behind the logarithm, but the exponent is going to go in front of the L. So this would end up being 7 log base x of q. Now let's combine all of these rules together and let's see if we can break down the following logarithms and put them into the sum and difference of logarithms. Okay, so how many expressions do I have here? I have an x to the 7th and a y to the 3rd. So I have two different expressions. I'm going to write two different logarithms with the same base of d. In this first expression, we're going to put that first. But remember that using our rule here for the power rule, this 7 is now going to go in front of the logarithm. So the x goes in the back and the exponent goes in the front. Here, y to the 3rd, y is going to go in the back, and the exponent of 3 is going to go in the front. Now think about what is happening between these two expressions. We are actually multiplying. So how does that change when we convert this to two logarithms? That changes from multiplication to addition. So we're going to put a plus sign there. Okay, let's look at this one. This one is also two expressions. So I'm going to write a logarithm with a base j and log base j, so I'll write it twice. The numerator is going to go on top. The numerator is going to go first since it's on top. Okay, so the x was going to go in the back. The 8, the exponent, is going in the front due to our power rule. And in the denominator, we have 7 z squared. We have z squared. The z is going to go in the back. The 2 is going in the front. And let's think about this. We're dividing. So when we divide, we're going to subtract. So we're going to put a minus sign there. Now 19 is a little bit longer. We have how many expressions here? So we have 1, 2, 3, 4. So we will write this log base k 4 times. Log base k, log base k, log base k, log base k. Now something I want to just mention real quick is that it really does not matter the order of how you write these, other than the exponent does have to go in front. But I could certainly have written 2 log jz, base j of z, first, and then that second. The most important thing to remember, though, is that the sign has to stay with that particular expression. So if the sign was supposed to be negative, when I rewrite this, if I was to move this to the front, that negative has to stay with that expression, that term, you should say. Why is that? Because anything that's in the numerator is going to be positive when you separate it, and anything in the denominator is going to be negative when you separate it. Anything in the numerator is positive in the front. Anything in the denominator is negative in the front. But the order really doesn't matter as long as you follow the sign rules. It is often much easier to do it in the order. Start at the numerator and then work your way down to the denominator. So that is what I'm going to do, but the concept that I just explained does come into play in the next few problems, okay? So here, I've separated into 4 so far. Now, what is our base here? We have x. Our exponent is 3. So x is going in the back, 3 is going in the front. Y squared, y goes in the back, 2 in the front. Z to the 9th, z in the back, 9 in the front. A to the 3rd, a in the back, 3 to the front. So now let's talk about signs. Again, if it's in the numerator, the sign in front is positive. If it's in the denominator, you're dividing. So those are going to be negative in front. So this one is in the numerator, so that would be a plus, and that would be a plus. Now I don't really need this plus because it's out front. It's understood to be positive. But I do need this plus here to separate those two terms. And these are both in the denominator, so they're both going to get a negative. Okay? So this is how we take a complicated logarithm and separate it into different logarithms. Now, we're going to work backwards. So let's say I have given you kind of like the answer for what we just did, and I want you to put those back together in a single logarithm. So we're kind of doing the reverse of all these rules we just learned. And instead of having 3 different logs like we do in 20, we want to convert it back to a single log. Now notice in 20, you do have logs 3 times, and the base is the same. So when we write our answer, we're going to use that same log and the same base. But we're only just writing it 1 time. We don't need 3 separate ones. We need a single logarithm for our answer. Okay? The next thing that I would suggest you do is just look at the problem and see if there's any minus or negative signs. If there are, that means that some of these expressions are going to end up in the denominator. So you know you're going to have a fraction. So go ahead and put a fraction bar. And then we need to kind of figure out what's going to go in the numerator and what's going to go in the denominator. So let's take this a step at a time. This is a positive term. So we know that when we figure this out, it's going to end up in the numerator of our answer. We also know that a number in the front represents the exponent for this particular x. So if you think about what we did up here, we took the 3 and we put it in the front. Now we're working backwards. So we're putting the 6 back up here with that x. So in the numerator, I'm going to have x to the 6th. Okay, now let's look at the next one. We have minus 5 log base b of y. The minus tells us that this expression is going to go in the denominator. And what expression is that? Well, that's going to be this 5 being back up the exponent. So I'll have y to the 5th, and it goes in the denominator because that's negative. And a similar thing here. This is negative, so I'm going to put this 3 back up as the exponent. So I'll have z to the 3rd in the denominator. I do want to make a quick point that even though these have negative signs, make sure that your answer, when you combine this back into a single logarithm, does not. So none of these are negative. Notice I don't have any negative signs in my answer. That is because the negative only shows up when you're taking it apart and making it separate logarithms. When you put it back together, those negative signs are not there anymore. Okay? Let's look at 21. First, identify the logarithm in its base. So our log is log, base is b. So we're just writing it as a single logarithm. Second, see if there's any negative signs. We do have a negative sign, so we know that the answer is going to have a fraction in it. Third, start on the left side and work your way to the right. So here, this ends up being the 5 is the exponent on the x. And this term is positive, so x to the 5th is going to end up going in the numerator for my answer. Next, I have minus log base b of y. So the minus tells me that this expression is going in the denominator. But this one's a little different because I don't have a number here. So what is that number understood to be? Well, it's just 1. So this 1 would just end up right here with the y. Y to the 1st is really just y. So this y by itself is going to be in the denominator. And then this 1/4, even if it's a fraction, this can still be up in the exponent. We discovered that maybe in previous units, previous parts to this video. So this is also plus, which tells me that this z to the 1/4 is going to go in the numerator. So we're pretty much done, but not quite. Depending on your system, they may want you to write this rational exponent as a more simplified form or a more accurate form. And that form is radical. So if we think back to how do we change a rational exponent to a radical expression, we need to do that here. So we're going to write this logarithm again. This is going to be equal log base b. The x to the 5th will stay the same, and this will still be over y. But how do I write this z to the 1/4 as a radical expression? So this is going to be z. The 1 ends up being the exponent. Well, I don't really need to write the 1. You could write it there, but you need to erase it later because it's just understood. And you know there will be a radical. And the index on that radical is the denominator of this fractional exponent. So the index right here is going to be 4. And you can't see that very well. Let me see if I can make this look a little better. Maybe that's better. So let me rewrite this just one more time so we can make sure we have the right answer. X to the 5th, 4th root of z over y. That would be your answer, and that would be how you would put it, the answer into whatever online algebra system that you have. So this is all the different rules of separating a logarithm into sum and difference of logs, and then turning that sum and difference of logs back into a single logarithmic form.